Okay, so the real number system. Give examples of natural numbers. Remember, natural numbers were counting numbers. So let's do well, first let me switch colors. So like 2 and 5 and 18. Cool. Give examples of whole numbers. So these were like the same thing, like 2, well, like 7, 16. But this is also 0, remember. Don't forget 0 is our special one. Okay, give example of integers. Let's go remind ourselves about integers. So this 0, so they're the whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, and they're negatives. So if I do something like 0, 10, 20, I can also include negative 15, negative 6, right? Rational numbers. So numbers that can be written as fractions. So let me just write a fraction first, like 4 over 5. Like these include decimals that end or repeat. So I don't know, negative 6.2, decimal that ends. Decimal that repeats, 0.1212121212. That will be a fraction. We don't know what it is, but like it can be written as a fraction because it repeats. Irrational numbers. Okay, irrational numbers, decimals that don't end, such as pi. Okay, so I can put pi in the square root of a non-perfect square. So pi and like square root of 23. And give examples of real numbers. So like any of these. So negative 6, negative 0.4, square root of 81, which is 9. Square root of 17, which is an irrational number. So 3. 3 is a natural number. So that means it's whole, it's integer, it's rational, it's real. So 3 is a natural number, which means it's a whole number, which means, well, let me change colors. Okay. 3 is a natural number. That means it's inside the whole, it's a whole number, it's an integer, it's rational. It's not irrational because it's rational. It can't be rational. It can't be rational and irrational. It has to be one or the other. 0. 0 was not a natural number. Because remember, the natural numbers are the counting numbers. Like a caveman doesn't think of 0, right? So, but it's a whole number, which means it's an integer, which means it's rational, but not irrational. If it's rational, it's not irrational. Negative 1. Negative 1 is an integer, but it's not a counting number. It's not a counting number and 0, so it's not natural or whole. So it's not natural, it's not whole, but it's an integer, it's rational, and if it's rational, it means it's not irrational. 3 over 2 is a number that can be written as a fraction. So those are like right here because it's not a whole number. It's not 1, 2, 3, 0, negatives. It's not counting numbers, it's not natural numbers, and it's not 0, right? So 3 over 2 is not natural, it's not a whole, it's not an integer, but it is rational, which means it's not irrational. 1.33 repeating. I had a problem before writing this little bar, so sometimes I just used to write this out. I think I just copied this part from something I did previously. So 1.33 repeating, that is not natural, that is not whole, that is not integer. If it's repeating, I can write it as a fraction, which means it's rational, which means it's not irrational. Square root of 8. Let me try that in my calculator. Square root of 8 is, about 2.828. It keeps going forever. It doesn't ever repeat. So this is not natural. This is not whole. This is not an integer. This is not rational because it doesn't repeat. It doesn't end. So this is irrational. This means it keeps going. Maybe I should write this a little more clearly. Goes on forever, which means it's not natural, not whole, not an integer, not rational. It's irrational. Okay, I guess one last section. Let's do orange. So all natural numbers are integers. So all natural. So all these natural are integer. So 1, 2, 3, 4 is also an integer. Yeah, that's true. So give one example if false and two if true. So an example would be 2 and, okay, all natural. So all natural. So 2 and 5 are natural numbers. And 2 and 5 are natural. Oops. Natural and integers. Okay, all integers are real. All of these integers are inside this entire thing called the real number system, or real numbers. So this is all real. Integers are real. Yes, let's take some integers like -4, 0, and 5 are integers and real. All right, some integers are also whole. So some of these, are they in here? Are some of these in here? So 0, 1, 2, 3, no, -3 isn't in here, -2 isn't in here, -1 isn't in here, is not in here. So -3, -2, -1 are not in whole numbers. But 0, 1, 2, 3 are, like they go in there. So that's true. So 0, 1, 2, 3 are integers and whole. Cool. And integers are irrational numbers. So integers are irrational. So integers are rational. No, they're completely separate, right? So integers are rational. So this is false. So it says integers are rational. So let's give some example. So 2 is an integer. 2 and 4, we'll say -4, are integers. But not irrational. Because remember, irrational numbers are decimals that keep going on forever and that don't repeat. And finally, irrational numbers can be natural. So let's look here. Irrational numbers can be natural. No, this side, this blue side, is separate from this red side. Natural are rational, and if they're rational, they're not irrational. So it's false. And for example, 2 and 5 are natural. 2 and 5 are natural, which means they're rational, which means not. Well, if they're not, oh yeah, which means not irrational. And that is it. Thank you.